Hi everyone, I hope you're doing good. Today I'm doing a little bit of preparation for the upcoming Waterloo competition, Canadian competing competition to be particular. It's very competitive, so I'm starting super early so I get the most amount of experience in. Okay, so here we have problem J2, chili peppers. I'm going to teach you guys this problem because I already know how to solve it. Um, I read through it, I know the concepts and everything, so let's get right into it. I'm using Replit for my IDE of choice. You could use the Python IDE that you get when you download Python in your machine. Anything really works, to be honest, but I just like Replit more because it's just right here. It's in the web, right? I don't have to download anything. But yeah, I'm going to use that. I did turn off AI, so I don't have AI autocomplete because that ruins the whole point of practicing, right? And let's get right into it. So Ron is cooking chili using an assortment of peppers. The spiciness of a pepper is measured in Scoville heat units, SHU. This means that SHU is simply an abbreviation for the spiciness of a pepper. Ron's chili is currently not spicy at all, but each time Ron adds a pepper, the total spiciness of the chili increases by the SHU value of that pepper. So chili in this case just means like the soup, like chili food. It's this over here, chili con carne. All right, this. It doesn't mean the actual like spicy chili thing. But yeah. All right. So the SHU values of the peppers available to Ron are shown in the following table. So we're given a key value relationship. All right. Now this is very, very important because it's going to link back to one of the concepts that I'm going to be implementing in my code. Your job is to determine the total spiciness of Ron's chili after he has finished adding the peppers. So now in the input specifications, what it's saying is that the first line will contain a positive integer n representing the number of peppers Ron adds to his chili. So I'll add that over here as just n, which just represents the number of peppers that Ron adds, right? And it's just going to be an integer. And then in the input, it's just going to be like this, all right? I'm not going to ask any questions or anything. It's just going to leave it blank. Okay, and now what we're going to do is for the next n lines. Remember, n is represented by the number of peppers, so that's literally this n that I have here. So for the next n lines, actually just means this variable here. Will each contain the name of a pepper Ron has added, right? So we can see that in the sample inputs, right? Like you put 4 as your first input, which is this, the n, right? And then after that, you only get 4 different available things that you can add, right? So that all it's really saying is that you can only add the amount of peppers that n is specified to. So for that to happen, we can just use a for loop. So for underscore in range, because I don't need a variable, so like because you usually do for a variable like I, or you can name it anything, right? But I don't need one, so I just use the underscore to specify that hey, I don't need a variable. In the range of n, range of n simply means since n by itself is actually not iterable. What do I mean by iterable? It just means moving through a specific data structure one by one, right? So in the case of a list, you just go from one item to the next, to the next, to the next. That's what for loops do. But n is actually an integer, right? It's just like 5 or 10 or 13. And by nature, you can't move through the values within Python. You can't move within the values of these when it's an integer format. So instead, what we do is we give it a range. Okay, so this means that, for example, let's say we have 4, right? It'll create a range of 1 to 4. And then it will just run until it reaches 4. All right? So until it reaches n. Okay, so it just creates exactly as it says, it creates a range of values and it just runs that many times. Okay, now what we're going to do is we're going to have another variable, and this variable is actually going to be the pepper. So for that, I'll just call it p. And in this case, we don't want it to make it an integer, right? We want it to be obviously a pepper, right? Like a string. Okay, and now that you understand that bit, let's just go back to the inputs here and I'll just make this a little bit bigger so it's easier to see. Um, and I'm just gonna go ahead and try to explain more of what's going on. Okay, so over here, what we did was we give it a value 4. That means that we get to add 4 peppers, which we did, right? And we have that functionality here. So for example, if I run this exact input here, right, I have to actually run the solution because I have it in a function. But yeah, so anyways, like let's say I have 4 and then I can just add anything. I'll just say P, C, T, P. You can see that I'm only allowed to run 4 different options, or 4 different of these inputs which represent the peppers, right? So we got that functionality nailed down to a T. But now we have to figure out how we can get an output. And what it's saying for the output, right, it gives us this number. Now what does this number mean? Well, it's the total number of SHU units between all of these 4 different peppers. So basically, a Pablino pepper has an SHU value of 1500. We can reference to the table for this, right? A cayenne pepper has a value of 40,000, and it keeps going on. And then all it did was it added all of these different values together. Okay, so how can we do this? Well, this is where the key value relationship actually comes into play. So this table here is represented in a key value relationship. Now, what do I mean by key value relationship? I just mean that there is a key which is related to a value. So it's a relationship between 2 different entities, right? In this case, it represents the relationship between a pepper and the amount of Scoville heat units. And this specific data type or data structure, right, or data format, you can even say, of key value pairs can be represented with a hash map, or in Python is called a dictionary. So here, back in my code, before we go into the for loop, I'll create a reference table so we can reference to these different peppers and their related Scoville heat units, or SHU. So I'll create a ref, and this is how you make a dictionary. I'm just gonna call it a dictionary. It also means hash map for people who know CS a little bit better. Now within here, all we need to do to represent a key value pair is have a key. The key is the pepper's names. Okay, so I'm gonna start off with Pablino, and then you just add a colon, and then you're gonna put in the number of heat units. I'm gonna keep that as an integer since we have to add these up at the end, and you can only add an integer. You could add like strings as well, but then they're gonna concatenate together. They're not gonna actually add like numerically, right? Let's do Mirasol as well. Let's do Sereno. Let's do Cayenne. This is something that many people might be familiar with. Cayenne, 40,000, right? Thai pepper, and that's going to be 7500. And then habanero is going to be 100,000, 250,000. And I just forgot to add a comma. So this is the syntax, right? So this represents a key value pair where the keys in this case are the pepper's names, just as Waterloo has depicted here, and then the Scoville heat units are the values, exactly the same here. Okay, so now back in our for loop, all we need to do now is we need to reference this ref. And actually, one thing I'm going to do is I'm going to make all of these lower cases. So I'm actually going to have my program made so that it does not matter about your case. Like, it's not case sensitive. So you could write in all caps, you could write in all lowercase, you could write in anything. It will still understand the different characters by standardizing the type of characters used. In our case, lowercase. So all I'm going to do is I'm going to say p dot p dot lower. This is just gonna make our input all in lowercase. That's all it will do. Okay, and now all we need to do is we need to just simply figure out what pepper it is. Okay, what pepper it is. So to do that, all we can do is we need to reference this ref table that we built, right? And to do that, what we can do is first of all, I'm gonna have a sum, I should say, of just 0, and all I'm gonna do here is I'm just gonna reference that sum, and I'm gonna actually increment it. So that's how you increment, plus equals, right? So we're gonna add to it, and since this sum is an integer, we can add to it, right? And we're gonna add the amount referenced in the peppers, and we get that pepper from the specific input. So in my case, it's gonna be ref p. So this is how you would get the value based off the key. So essentially all we did was, for example, let's say I typed cayenne, all right, or poblano. I don't know how to pronounce it, but anyways, I would type poblano, right? That is our key, remember, because the pepper names are the keys, right? First of the two in the key value pair is the key. Through this syntax, all I did was I told Python to go ahead and find this key and then give me the corresponding value. So this will be actually, if this was poblano, it would be actually 1,500, right? Because it's the same thing over here. All right, and so that's exactly the functionality we want here, right? We want to get the SHU based off of its corresponding pepper. Okay, now all we need to do is we need to print this off. So to do that, all I'm gonna do is I'm gonna return it. I'm not gonna print it because with returning, it'll be the value. Whenever you call the solution itself will be the value of the output, and that way you can use that data for anything else, right? That's just a best practice you should remember. But yeah, we're gonna return the sum, and in this case I'm just gonna want to print it, right? Just for demonstration purposes, but usually Waterloo or your teacher or something, they'd have some sort of submission process. But yeah, let's try our sample input we were given. So for poblano, cayenne, thigh, poblano. And as you can see, we get the same output, meaning it works. One thing that I will actually do here though is I'll say if p not in ref, return invalid pepper. This simply means that if this p is not a key, right? Because remember, the pepper names are the keys. So if p is not a key within the ref dictionary, we're gonna break out of the function itself, not even the for loop, the whole function, right? And just give the message of invalid pepper because you did not give us a valid pepper, right? That is recognized. So it doesn't make sense to continue on, right? So that's just a bit of error handling done. So let's do the same thing again. And so for, in this case, I'm gonna mess around with the different casings, right? And you'll see that it works the exact same. As you can see, it works exactly the same because, again, as I said before, it standardizes everything into lowercase, so all of these become lowercase, so it can be recognized and dealt with, right? But there you go. Now let's say I'm just going to use 1 in this case. Let's say I give something that's not part of it. As you can see, it gives me invalid pepper, and let me first put in something that is part of the ref, right? Poblano. Oh, I said 1, my bad, hold on. So poblano, and then I can go ahead and go crazy here, and as you can see, it will immediately stop the operation, so you can't add more, right? Because obviously you're probably not doing something correct if you're giving an incorrect pepper name. So that is it from me, guys.